Thank you for joining this lesson. Today we are discussing mathematics paper 2, the Kcse 2023 examination. So I believe you shall cooperate. I believe you are inviting someone to this lesson. Remember to subscribe. Remember to share with your friends. We go to the paper direct. That is a Kcse examination mathematics paper 2. Just a minute. I'm trying to get a paper to be written. Yeah, this is at least this one can be edited. So let's look at this paper. It's a logarithm equation, the first question. Yeah, remember to invite someone. Yeah, today we are saying hi to mathematics teachers. Remember to tag your teacher today. Just say hi to your good mathematics teacher. Like this video and share. Okay, we are solving a logarithm equation here. 1 plus the log of 2x minus 9 equals to the logarithm of 3x plus 5 minus the log of 2. So when you look at the first solution, we are saying that instead of 1, we can apply the law of logarithm, which says that the log to a number, or the log of a number to the same base, is usually given by 1. Therefore, we apply the log to base 10 in this equation, such that when we write the log of 10 to base 10, then the meaning of the value of 1 is not affected. And with that now, when we introduce logarithms where there is this constant, we can apply the law of logarithm, which says in case there is a plus between two logarithms, let's say for example, we have the log of A plus the log of B. We can simply solve this by taking the log of A multiplied by B. We just multiply the two numbers. And so we can say at this point, we just apply. In case it's a minus, then we would say the log of A minus the log of B. This is equal to log A divided by B. We just divide the two numbers. So at that point now, on the right hand side, there is a minus. On the left hand side, there is a plus. So we'll be multiplying 10, because the bases are the same, 10 by 2x plus 9, while on the other side, we'll be dividing 3x plus 5 by 2, because it's a negative. So now we can open the brackets here and say 10, 9 is 90. This is equal to 3x plus 5 out of 2, just as you can see them. Then from there, now we can drop logarithms and we equate the two sides such that when 2 multiplies the other side, we can multiply by 2 both sides and also by 2. So that we have a 40x minus 180 equals to 3x plus 5. And we group like terms together by taking 3x to this side. So it becomes 37 x equals to 185. And finally, the value of x, when we divide it through by 37, becomes 5. Just becomes 5. So that one is already settled. Yeah, there can be several approaches. There can be several approaches to that. Just as you can see, the log of 2x minus 9 at this side, which will be the same, which will exactly be the same. So we don't even have to complicate the question. It's already simple. Two masses, or the masses of two students in a class, were measured as 30.5 kilogram and 36.8 kilogram. Determine the least possible difference in the masses of the two students. This is on errors and approximations. We must know that according to the recording of these masses, which has happened to the accuracy of 1 decimal place, there is what we call absolute error in the recording. So the absolute error in the recording, due to the 1 decimal place, is going to be the accuracy of 0.1 divided by 2. This is absolute error in the recording. So 0.05 kg. This is the absolute error when the masses were being recorded. And with this, we can now talk about the range of each value. The first mass, which is 30.5, according to this, is ranging from when we add or subtract. Actually, we just take 30.5, then we add or subtract 0.05, which means the range is going to be from 30.55 to 30.44. This one is the least mass. And for the other one, which is a 36.8, we also add or subtract the same, because the accuracy in both cases is of 1 decimal place. So we shall have this one being the maximum, 36.85 kg, and the least being 36.75. Now we have a maximum and minimum dimensions for both measurements. What we are determining now is the least possible difference. When we are subtracting, for us to get the least difference, we have to use, in the bigger value, we use the small value. Remember, we want the least difference. So we will take the smallest value in the bigger measurement. We subtract the greatest value in the least measurement. So it will be 36.75. And we subtract. This one will give us a difference of 6.2 kilogram, which is the least difference. In case you subtract anything else, you can get any other difference, but this one becomes the least. There is a question here on a question on changing the subject of a formula. Make x the subject of the formula a equals to bx out of the square root of x minus 9. Remember the subject is now a, and the examiner wants us to change it from a to x. So we can start by squaring everything so that the square root sign is done away with. And so when we square, a will become squared equals to, b will also be squared, and x will be squared. Each variable is squared independently. There is no need of saying b and x into brackets squared. No. We just square each one independently. Then we divide by, when you square the denominator, the square root sign disappears and it will be minus 9. X squared minus 9. So with that, let's cross multiply actually. And when you cross multiply, you shall have a squared, x squared, then minus a squared 9 or 9a squared equals to b squared x squared. At this point now, the terms with x can be brought together. The terms with x can be brought together. And in such a case, we will talk about a squared x squared minus b squared x squared equals to 9a squared equals to 9a squared. So with this, we can factor out x and have a squared remaining, then b squared. Yeah. When we factor out x squared, we shall remain with a squared and b squared equals to 9a squared. So that will remain with x squared. Then we have to divide it through by a squared minus b squared. So we shall have 9a squared divided by a squared minus b squared. So at that point, now we can take square root of both sides. We can take square root of both sides so that we get now the exact value of x. Continue joining. I can see people are coming in. Remember to subscribe. Remember to share. Invite a candidate tonight. Invite a candidate to revise with us. Thank you so much for being around. Thank you so much for being around. Okay. So now to wind up, we can say the value of x, because that is x squared now, will be when we obtain square root. And it's good to have plus or minus, because a square root will have either those, either plus or minus the value. Okay, 9a squared divided by a squared minus b squared. We can simplify further and say the square root of 9a squared is known. That is exactly 3a, then divided by, now on the denominator, the square root sign remains, but again, we are supposed to know that the denominator is now a difference of two squares. Therefore, instead of leaving it that way, we can have it simplified in that a squared minus b squared now becomes a minus b, a plus b. Now that is it. Remember our plus or minus to be at that point. So this is the value of x, and we have now made it the subject of the formula. Remember, the consultation line remains to be 0, 7, 0, 4, 1, 5, 3, 6. This is the consultation line for this platform. Remember to share the link with friends. Remember to invite other candidates. Number 4, in this section, use a ruler and a pair of compasses. That means there will be no measurement of angles using protractors. The question proceeds to tell us that the following figure shows a circle, center O, a tangent to the circle at P is drawn. As you can see, this is a tangent to the circle at P. Then construct another tangent to the circle to intersect to the drawn tangent at an angle of 60. So it's good for you to know some properties of angles when circles are involved. You should know that in case a line through the point of contact between a tangent and a circle perpendicularly, that point will pass through the center of the circle. In other words, a radius cuts what we call a tangent at an angle of 90. So automatically this is 90 and this is a radius, which means now if we want another tangent to be drawn so that the first one is cut at an angle of 60, then we are supposed to ensure that because the line from the center to the point of intersection of the two tangents divide the angle between the two tangents into two. We are supposed to ensure that the angle there is going to be 30. And for the angle there to be 30, remember it's a point that we don't know. So we are supposed to ensure that we already know this is T and this is 90. We expect that to be here. So automatically at the center, we need to produce 60 degrees. So we just construct 60 degrees. By standing at this point, we make an arc, and starting on the arc, we make another arc. Then we produce our line now, such that wherever it you cut the first tangent, that will be 30 degrees. And now after you've measured 30 degrees there, or you have made a 30 degrees angle there, now you stand at that point to add another 30. Once you add 30, or you can even now construct 60. You can just construct 60 and you produce it. That 60 will lead us to, if you produce the 60 until it touches the circle, then you will discover that it is the intended tangent. That is the tangent that we want. So that is good. Yeah, I can see people are still following. Remember to invite a friend. Remember to invite a classmate. Yeah, I told the people today. I can see Mboni boys in the room. Wonderful. Emmanuel Springs represented. That is Emmanuel Springs in Makueni. That is wonderful. Menengai High. This is great. This is great. This is great. Anesta Boys High School, Lanet. This is wonderful. This is wonderful. Wow, this is great. Continue saying hi to your math teacher. You can say people are greeting Mr. Motheni McB. People are greeting Mr. Mwanthi McB, Mr. Moses. Wow, this is great. This is great. Thank you, math teachers, for the good work that you're doing to these students. Okay, let's continue learning together. Number 5. A plane took 3 hours to fly from P, which is 63 degrees, 66.42 degrees north, 30 degrees in the east, to Q, 66.42 degrees in the north, 52.5 degrees in the east. Determine the speed of the plane in knots, correct to 1 decimal place. Very special instructions. The speed must be in knots and to the accuracy of 1 decimal place. It's very good for students to know that when speed is in knots, then it means the distance is in nautical miles. Now, from point P to Q, we can see that they are on the same latitude 66.42. Let me sketch the location of those places. Just a sketch. This is the prime meridian. This one is equator. Then we are talking of 66 now. 66.42. degrees north. Then we have let me draw using a different ink. Now we can have in the east, they are both in the east. Therefore, we are having a 30 degrees in the east. And we are also having 52.5 degrees in the east. Yeah. So this is place P. Then we are moving to place Q. After sketching the places, you will be very lucky to observe in advance the kind of a path or the kind of a circle between the two places. So from P to Q, definitely we are moving along the parallel of latitude. So along a small circle. The distance in nautical miles across a small circle is given by 60 multiplied by the angle difference between the two places. That is the longitude difference. Then cosine of the latitude, cosine of the latitude where the two places are. So we can say 60 times the longitude difference. When we are moving from 30 degrees east towards 52 degrees, still in the east, then we need to take the difference between the two because they are both on the same side of the equator, the same side of the prime meridian. It means the angle difference between the two should be the difference, and this will give us 22.5. Then multiplied by the cosine of the latitude, we are on latitude 66.42 degrees. So this is going to give us the distance 60 multiplied by 22.5, then the cosine of 66.42, giving us a 60 times 22.5 multiplied by the cosine of 66.42. This gives us a distance of exactly 540.04. 540.04 nautical miles. Remember, when you've been told to one decimal place, it is the final answer which is supposed to be to that accuracy, not anything else as you continue working. So the accuracy is all about the final answer. I hope we are together in that. Okay, the question was on speed anyway. Speed is given by distance out of time. The distance must be in nautical miles. So 540.04 divided by the plane took 3 hours. So when you divide this by 3, I'm getting 18 or 180, sorry, 180.01. 180.01. That means to one decimal place, it will be 180.0. The speed is in knots. The speed is in knots. So that is the speed which used. Remember to subscribe. Remember to share with them. We are now going to solve another question here, which is on a, let me use a different ink. The question is on trigonometry. 6 cosine squared of x equals to 5 sine x for the range of x between 0 and 180. Between 0 and 180. So we are supposed to know that there is the trigonometric identity, which says that when we have the sine squared of x, to be general, then we get back to the question now. When we are supposed to get one, we have cosine squared, then this identity can be expressed now such that cosine squared of theta equals to 1 is sine squared of theta. Then now with this cosine squared of theta, we have 1 minus the sine squared of theta. So we apply this identity now in the first term here, whereby it will be 6 instead of cosine squared of x, we can have 1 minus sine squared of x. This is equal to 5, the sine of x. At that level now, we can talk about 6 minus 6 sine squared of x equals to 5 sine of x. We can now rearrange this equation such that it takes a quadratic shape. Actually, the negative 6x or 6 sine squared of x can be taken to the right-hand side, whereby it becomes positive. So 6 sine squared of x. Then we find there is 5 there, sine of x. Then now we bring 6, whereby it becomes minus, equals to a 0. Now we can say, if we let the sine of x to be, let's say, t, then we will talk about 60 squared plus 5t minus 6 equivalent to 0. Minus 6 equivalent to 0. Continue following. Remember, you should be subscribed to this. Remember, you should be subscribed to this channel. Ekwanda boys, wonderful. You do a lot for us, sir. Thanks so much. May God bless you. I'm Joash from Namanchanja High School. This is a great Makueni boys in the room. This is wonderful, Makueni boys. Thank you for turning up. Representing Menengai High. That is wonderful. Why do we find the square of the denominator? Mboni boys in the room. Anesta boys. Emmanuel Springs. This is wonderful. This is great. This is great. Machako School. Wonderful. That is my school. Those are my getting me clear. Wow, St. Stephen Mosalala, that is great, from Kilungu. I know you need to see my screen. Okay, so we are at the quadratic equation, whereby now we can solve it to get the value of t. There are, of course, two values of t, whereby we need a product of negative 36. We need a sum of 5. These two applied, they give us a negative 36, and when we add them, they give us 5. They must be 9. They must be 9 and negative 4. 9 and negative 4. We substitute them now. Instead of 5t, let me solve the equation. For those who don't know how to solve quadratic equation, and flow together up to the last point. This means that we need 60 squared. Now, instead of 5t, we can have a 9t. Then we subtract 4t. Then minus 6 equals to remain with the 2t and 3. Then minus 2, so that we remain with 2 positive 3 equals to 0. If that is equal to 0, it means we can pick 2t plus 3 equals to 0. And that means the value of t will be negative 1.5. 3t minus 2 equals to 0. The other factor here, 3t minus 2 equals to 0, which is or 2 out of 3. Now we tell ourselves that it is the value of sine x, which we t. This means sine x now equals to 2/3. Sine x equals to 2/3. To get x, we need the sine inverse. Shift sine 2/3. Shift sine 2/3. You're supposed to be getting 41.81. 41.81 degrees. That is the acute angle. But remember the range that we have been given between 0 and 180. Therefore, we should tell ourselves that according to the unit circle, we need another quadrant. Remember, 41.81 is just an acute angle in the first quadrant. But now we should work with the other quadrant where signs are positive. And we also, then there is a 41.81, but quadrant. So in the second quadrant of the unit circle, we also have signs. So we need to take 180 and we subtract 41.81, and this gives us a 138. 100, and so the other value is, say, the 41.81. So the other value should be 138 degrees. So those are the angles. Because which is negative 1.5, it's not practical to have the value of a sine being greater than 1. We also don't have cosines being the same, but tangents can be. So when cosine goes beyond 1, that one is not applicable. So we work with only those two angles. Number 7, the following table shows the frequency distribution of marks scored by 40 students in a test. 40 students in a test. So we have the marks in classes. We got the respective frequencies for these classes. Calculate the upper quartile mark, the upper quartile. It's good for you to know that the upper quartile is also called the Q3 of a given set of data. Now we should median divides data into 2. After data has been split into 2 by median, now the upper can also be divided into 2. In other words, it's talking about median for the upper set of data. That is what we call Q3, the upper quartile. Now, after median again, there is the lower set of data, whereby the lower set of data can also have a median on its own. And so we can say that the median for the lower set of data, the lower quartile, sometimes it's called the Q1. So in this case, when we are talking about Q3, we mean the median for the upper set of data, and Q3 is usually given by the lower class boundary plus 3/4 of the total frequency minus cumulative frequency just before the Q3 class. This one is divided by frequency of the Q3 class multiplied the class length of the same. The first thing we are going to do here is to obtain such a class. So we need to get 3/4 of the total frequency. The examiner is saying that this is for 40 students. So total frequency is 40, which means we are working with the 30th. And the mark scored by the student. It's also good for you to understand something else. we can get what we call cumulative frequencies. We start with 4, then we get 14, 14 plus 13, we get 27, 27 plus 8, we get 35, and finally plus 5, we get 40. We get 40. So we're talking about the 30th student. Which class will accommodate the 30th student? The first one, they are only 4. By the time we're in the second one, 14. The third one, 27. But in the fourth class, whereby we are, that is where the 30th student is. And so that becomes our Q3 class. Our Q3 class. So we determine now the Q3 by following that class. The lower boundary for such a class is 40.5 plus 3/4 of total frequency, which is 30. We subtract C, which is cumulative frequency just before this class, 27, divided by frequency for the particular class. The class has a frequency of 8. Then we shall multiply this by the class width from 41 to 45. The lower boundary is 40.5, the upper boundary 45.5. So we are getting 5 as the class width. Then we compute now the upper quartile, and we will find our 2.375. That is the mark, which will be called upper quartile. That is the upper quartile. Upper quartile. I can say you guys are seriously chatting. Wow. SCK St. Mary Sukia girls. This is wonderful. This is great. This is great. Wow. Number 8. Given that P, this is a vector, of course, now. Vector P equals to 5i minus j plus 3k. Then vector Q equals to 8i plus, and that vector R is given by 2 minus Q. Determine the magnitude of R. So we are going to use the position vectors of P and Q to describe R. Remember, R is given by, when we take 2, let me write them as column vectors. P will be 5, then -1, then 3. Then we have minus Q. So we subtract vector Q, which is vector Q is given by 8i. So we start with 8, and j, which is 1. Then now, because the third axis is not provided, it means it's a 0. In that case, it is just a 0. So we can find this vector now, whereby we have 2 by minus 8, we get 2 units for the x. 2 by -1, we get a -2, minus 1, you get -3. Then there is a 2 by 3, 6, minus 0, it remains to be 6. It remains to be 6. So now, after we've gotten the vector R, we can now find its magnitude, whereby the magnitude of vector R, expressed this way, is going to be 2 squared plus -3 also squared, and we add 6 squared. Then we carry out the square root. The square root of 2 squared is 4, -3 squared is 9, and 6 squared is 36. This giving us exactly 49. So when we are obtaining the square root now, we're going to get exactly 7 units. This is the length, or rather the vector's magnitude. The magnitude of a vector can also be called the modulus of the vector. We continue. Number 9, the following figure shows a circle center O. Now this is a circle center O. We can see the axis where the circle is lying. Then we are told to determine the equation of the circle. We can't determine equation unless we know the of the center and also the radius of the circle. When you look at this, you will be able to know that the center is a coordinate which can be read. This is a x coordinate of 1 because this is 1. And for the y, it's now between 1 and 2, which means 1.5. So this is the center for such a circle. That is the center. Then we are having the radius now, which will be the length from the center to the circumference. And we can see that according to the scale, we will have 1 unit, 2 units. Therefore, the radius is going to be 2. We should be able to know that the equation of a circle is usually expressed by x minus a squared plus y minus b squared equals to the radius also squared. Squared plus y minus b, so 1.5 also squared. This is equal to the radius of 2 also squared. That becomes 4. Remember, a and b are the coordinates of the center. A and b are the coordinates of the center of the circle, the center of the circle. At that point, actually, at that point, it's good for me to mention that the equation is already complete because the examiner has not specified the format. So at that point, you have the general equation. It's already correct. It's already correct. Okay, we are told in part B, use the equation in part A to determine the x-intercept of the circle correct to 3 decimal places. You know, the x-intercept can be read from the circle itself. It is the point where the circle is cutting the x-axis. This point and this point, we can read them. But now the examiner is very categorical in this case. They are saying we calculate now to 3 decimal places. From the graph, you cannot have an accuracy of 3 decimal places. We have now to follow the equation, which is as above. It is x minus plus y minus 1.5 squared equals to 4. We are going to use to determine x-intercept. And we should know that at the x-intercept, the value of y is usually 0. So we substitute 0 in the place of y. And this will be x minus 1 squared, which will be x squared minus 2x plus 1. Therefore, it will be 1.5 squared. Let me get that. 1.5, when we square, we get 2.25. It will become positive, remember? 2.25. This is solved for the 2 possible values of the x-intercept. So x squared minus, let me even use the completing square method, equals to 4. We have 4 minus 2.25, then also minus 1. And I'm getting 0.7. I think the completing square method, perfect square, by adding a constant, which has also to be added on the other side. The constant c is usually given by b out of 2. squared. So the coefficient of x in this case is going to be -2. So -2 over 2, then we square, we shall get exactly 1. We get exactly 1 because this is -1 squared. So we get 1, and we also add 1 to the other side. So we will be having a 1.75. But for this case, we can factorize the left-hand side, whereby you need the square root of x. This is x. The sign which follows is a minus. The square root of this part is 1 squared. So now with the factorized difference, or with the factorized, we call it with the factorized perfect square, we can now take square roots for both sides, whereby we shall just remain with x minus 1 equals to the square root of 1.5 now. The square root of 1.75 is going to be 1.323. 1.323. So that to remain, remember this should be plus or minus, sorry, plus or minus 1.323. To remain with x, now we are supposed to add 1 to those two possible values. And the other value of x is equals to negative, we will have a, let me make, then we add 1, and we are getting negative 0.323. So we have this possible value of x-intercept, the possible value of x-intercept. So when we talk of x-intercept, whether we are dealing with curves, whether we are dealing with circles, whether we are dealing with straight lines, those are points where the value of y becomes 0. The x-intercept, the point where, or whatever function it is, where it cuts the x, or the horizontal axis. The horizontal axis. Girls in it. Wonderful. Thank you, Kcse girls, for turning up. Actually, this is courtesy of your teachers. Some of you received the link, information about this platform from your respective mathematics teachers who are very great friends of me. So kindly send my regards to the mathematics teachers. Remember to be subscribed. Your work is appreciated, sir. Thank you so much. I also appreciate you for following up. Let us look at this question on commercial arithmetic, which is on a back taxation, rather reverse taxation. The following table shows monthly income tax rates of a certain year. We have the monthly income in Kenya shillings, and we also have the tax rates in pounds in each shilling. Between 0 and 24,000, then we have the tax of 10, then the brackets follow, as you can see. We go to the information now, which says that 2,400 Kenya shillings was allowed. A monthly tax relief was allowed. The net tax on Lesianto's monthly income was 1,500 Kenya shillings. Calculate Lesianto's monthly income. Want to know the income of this gentleman called Lesianto? You to know that because we are given the relief and also the net tax, then we can start by calculating tax. For us to get gross tax, we have to take the net tax of 1,500 and we add the relief back, so that the expected total tax or gross tax would have been 3,900, only that there was a relief. Only that there was a relief. So now this is the total tax that we can get from the income of Lesianto. So we are going to tax a certain unknown amount until the tax adds up to 3,900. So we start. In the first bracket, we have 24,000 being taxed at the rate of 10%. And this will give us exactly 2,400 Kenya shillings. Now, in the next bracket, the tax is going to be, when we take 32,333 and we subtract 24,000, we are having a taxable income of 83.33. So let me just work it out here. 83.33 at the rate of 25%. So when I multiply this by 25%, I'm getting 2,000. I'm getting a tax of 2,083.25. Which means now, when we add this to the first bracket of 2400, we are going beyond. We are going beyond 3900. And if we are going beyond 3900, then it means now this is the last bracket, and amount now in this last bracket. This last amount can be let to be Y, which must be taxed at the rate of 25 to give us a certain tax, which when added to 2400, we should get 3900. So that amount which must be added to 2400 to get that 900 can also be calculated, and this is going to be 1500. So we get a tax of 1500. Yeah, 1500, which means the amount which is being taxed now can be also calculated. You see, the tax is now adding up to the expected total tax of 3900. That means there is an amount Y at the rate of 25. For us to get Y, we need to take 1500 times 100. We divide by 25. So it's like we are multiplying this by 4 now, equals to 1,000. So when we tax 20 at the rate of 10, when we tax 6,000 now, this is rate of 25, we are getting 1500. Adds up to 3900. This means now the taxable income, which is also monthly income for this gentleman, is now going to be whatever we tax now, 24,000, and we add 1,000. This is going to give us exactly 30,000. Exactly 30. Number 11. Wow, you guys are increasing from Pika. Wonderful. Watching from Sierra Leone.